All right, I have two more examples for you to take a look at and see if you can determine why these graphs are misleading. So both of these are on your guided notes. This first one is about quiz scores from a student named Patty. So I'd love for you to go ahead and pause the video and give this one a try. All right, so hopefully you paused that and gave that a try. The first question says, what is your first impression of Patty's quiz score? So this is kind of without looking at the numbers, just looking at what the line itself is doing. What would you guess is going on? So when I first look at this, I see the first part of the graph is kind of dead center on that vertical axis. So kind of looks like she's getting C's, maybe those B's, that she got up to an A, kind of dropped down close to a C again, and then started back up. Okay, that would be kind of just my guess by looking at that. But instead, if I look at this a whole lot more closely, what I see is that the very bottom of the graph starts at 76. So it doesn't start at 0, which I assumed that it started at 0. So the bottom of the graph would be like an F, the middle would be a C, the top would be an A. Instead, it starts at a 76%, which is like a C, C plus. So the lowest part of the graph is just a C, and then the top part of the graph only goes to a 92%. So really what's going on is most of Patty's grades are in the B's. Sometimes she just gets up into that A range, down into the B's, back into the A range. So really Patty's doing a pretty good job overall as a student, and her quiz score should hopefully make her pretty happy. All right, the next one, I have two different graphs for you. These are comparing temperature in Hawaii. Okay, so we have two different graphs here with two different scales. So thank you to pause the video, take a second and think, which graph do you think is a more accurate representation of those temperatures? All right, so let's take a look at these two graphs. The graph is kind of in the middle of the PowerPoint slide, but to the left of the two we're considering. That graph is going by 5-degree temperature jumps. And then the graph on the far right of the PowerPoint slide is going by 2-degree temperature jumps. So it's growing more slowly as you go up the graph, which means it's going to appear more steep. Okay, so which one is the better one to show? Well, this one is actually going to require that you have a little bit of background knowledge about air temperatures and water temperatures and how people react to those. So I used to be a lifeguard, and water temperature is like kind of a really big deal with swimmers, and especially with people in therapy classes. They really need that water temperature to be at a level that's helpful to them. It doesn't make their condition worse. So they're very, very sensitive to that water temperature. And so even a 1/2 degree temperature difference in the water feels enormous. Okay. In fact, the Olympic pools are kept between 76 and 79 degrees. So there's a 4-degree temperature window. If it's outside of that, they don't swim. Okay, so water temperature, people feel that dramatically. Even a 1/2 degree feels like an enormous difference. Whereas air temperature, people don't really notice that as much for a small, I mean, there's zero chance I could tell you that the air temperature decreased by 1/2 degree. You know, I could tell, you know, maybe if it went up by 5 degrees, I'll be like, oh, it's feeling a little chilly. Oh, it's feeling a little toasty. But, you know, it's really 5+ degree temperature changes that make a difference in how people perceive that as far as air temp. So between these two graphs, if I was looking at air temperature, I would use this one that goes by 5s, because air temperature people don't feel as dramatically. And so if the air temperature is between the 70s and 80s, it's like, that's a little too hot. Okay, it's better now. Okay, whereas water temperature, there is a huge difference between 70 and 80 degrees in water temperature. And so for water temperature, I would use that graph that goes by 2s and shows a much more dramatic increase and decrease. Okay, so sometimes the right graph isn't so easy to discern unless you know more about the subject matter material.